Right, so pre-algebra, and we're going to cover about 8 chapters this semester, and 2 lessons for each chapter almost. Right. So the first chapter may be trivial to you, but I'm not sure you already understand all the concepts. So I'm trying to explain to you this concept and the terminologies. I hope the problem itself is not that difficult. Okay. So in mathematics, we were talking about numbers. Now, come to your mind, what are the numbers? Numbers usually use deliver this those as 1, 2, 3, 4, 5. Questions is 1.2 is a number. Then say, oh yes, but sometimes when you think about, you are in the elementary school. So when you think about numbers, usually we're thinking about those we call the integers. Okay, integers, and and actually integers are numbers, but numbers mean include more, right? So we have numbers. When we talk about numbers, okay, we have integers, okay, and the rational numbers, and then also irrational numbers. It's very hard to understand irrational numbers. We probably are not going to go to that level. Okay, so integers are the integers are those numbers 0, 1, 2, 3. Those are the integers. Okay, and form and positive integers means 1, 2, 3, 4, 5, 6. Okay, and those are also called natural numbers or whole numbers. Okay, and those are the sometimes in the book you can see that, and those natural numbers means the positive integers. Okay, positive integers have different names. Positive integers are those are called the natural numbers, because those are the numbers human being first invented. Okay, nature, you count the apple, 1, 2, 3, 4, 5, 6, right? So those are got the nature, why it's called the natural numbers. And whole numbers are including positive integers. Now non-negative integers are called whole numbers. Lots of people use it as a whole number. Okay, non-negative. Now then we have to talk about negative things, right? Non-negative integers means the integers including zero. Okay, so that's called zero is a concept of zero. Okay, the notation zero actually was introduced much later, okay, by human being. Okay, now those are called integers. And how do we describe the numbers? Okay, we use a coordinate line. We also call the number line. I have to talk about this one. Yeah, this is a number line. Okay, and let me draw the picture. Okay. Number line in geometry is also called coordinate line. Okay, so this is a kind of a strict line. Okay, and there's origin. We mark it as origin, and then we choose a unit, 1 unit. Okay, this is called the 1. Then you mark it 1, you copy it and get it's 2, and the 3, and the 4. You mark that point by 5, and then the negative in the other side, I have to put negative sign here. It's called a -1, -2, -3, -4. Okay, so now do you understand what this means negative here? Negative integers are the integers. Okay, it's on the left-hand side. So there's a correspondence between a point on the coordinate line. On the line, there's a correspondence. Integers could be negative right? Integers, there is one-to-one corresponds point on the number line. Okay, so given integers corresponds those are special points. Okay, but in general, you were thinking about a number. Okay, corresponds to just a point on the number line. Okay. So how can I see that? You see, I have a strict line and I have 0 and 1 and 2, right? And 3. And how about this point between 0 and 1? But this point, there should be a number corresponding to that, right? Okay. And if this point is in the middle, and then the number corresponding to this point, or the number described by this point is going to be 0.5. So 0.5 is a number, right? Or depends how do you describe that point, describe that number. So 0.5 is a number, and it corresponds to the middle point between the point 0 and 1, okay, on the coordinate line, on the number line. Now this 0.5 is a rational number. It's not integer, right? So this is we call it rational number. Rational number in mathematics are the numbers. If you use a decimal in a decimal form, as the numbers was a terminate integers. Okay. So let me. What is the definition of a rational number? Okay, rational number is something like that, 0.2145, and maybe 54.221, and those are the rational numbers. But it's also possible it's going to be like infinite many integers repeating. Those are also rational numbers. Yeah, it could be 2 digits repeating. So those are the rational numbers. Okay. Now there's another way to describe rational number. Is going to be an integer over integer. Okay, this is going to be an integer over another integer. That's called a fraction. Okay, so rational numbers can be expressed as a fraction. Okay, and there's another concept, 0.5, and this is going to be 1 over 2. Okay. That means 1 divided by 2, you get 0.5 if you know how to do the division. Okay, so we probably talk about the fractions a little bit later, and this is a fractions, okay? And the 0.3333 infinite, this also can be converted to 1/3, okay? So 1/3 is 1 divided by 3, okay? The geometric meaning of 1/3 is this. Here's a number line, 0. That's a 1, right? And you divide it equally into 3 parts. This is going to be 1/3, okay? And there's a distance between 0 and 1/3, right? Okay, this is 0.3333. Now it depends on which notation. You have 2 notations to describe rational numbers. Use a fraction, which is integer over integer, and also use this in the decimal form. Okay. Now, when I was a child, right, how did I learn, how did I understand the addition and multiplication, subtraction? Okay? We're not going to study subtraction today, but addition is usually you can use this is about addition. Let's do the addition. There are 2 different ways to do the addition. Okay. And if this is 0, 1, and 2, okay, like a 2 plus 3, okay, that's a 5, right? Now, how do you do the addition? Use a number line, okay? So 2 is here, okay? 2 addition, 2 steps to the right. 1 step, 1 step, 2. Then 3 means 3 steps. 1, 2, 3. So you land here. So that's a 5, okay? So 2 plus 3. Another way to understand the addition 2 is you have 2 sticks, and you have yeah, you have 3 sticks here. Okay, and total put it together, you have 5 sticks. That's addition. Okay, add them together. Okay, this is another way to study addition. Okay, so now let's look at a simple situation. 2 plus 3 equals 3 plus 2. What does that mean? Okay, so what does this mean? That means, the order doesn't matter, right? 2 sticks plus 3 sticks equals 5 sticks, but you can say also 3 sticks plus 2 sticks. There's no bigger difference, right? So it's the same actually. So that is the reason 2 plus 3 and equals 3 plus 2, they all equals 5, 5, 5. Okay. Yeah, because it's addition. Okay. So just because when you add them together, you put together, there's no, doesn't matter. The order doesn't matter which one first. But when you talk about subtraction, it's quite different. We will talk about this later. All right. Another important thing, yeah, this one we can summarize. Let's summarize the rule. Okay, it's called the commutative rule. Okay, this is a commutative rule. Commutative rule for the addition. So A plus B should be equal to B plus A. So there's no difference. You can always switch the order. Okay, that's addition. Okay. Then, yeah, we have several rules here. Now, let's take a look at the 2 plus 3 plus. When you say plus, you do addition, you're only talking about a pairs of numbers. So if you have 3 numbers, what does that mean? To add the 3 numbers together. And you have to pair by pair to do that. So for example, like this one, I can easily to see that I can do the 3 plus 5 first, then 2 plus 5, right? So this is a 5 plus 5, and this is a 2 plus 8. They should be equal, okay? They're all equal to 10, okay? And it's easy to understand. Doesn't matter which pair of the numbers you can, which pair of the numbers you can do first. When we talk about addition, we only talk about, we do that for pair of the numbers, okay? That's because addition, that's a definition, how to add the 2 numbers together. You have to 2 numbers only, okay? And of course, we can extend this definition a little bit later. So here, this is always true, right? It's easy to see that you have 2 sticks plus 3 sticks total, add them together first, mixed up them first, then you put another box of 5 sticks there, then mixed up them up, total 10. And it's easy to see why this is always true. Okay, so then we can so-called as associative rule for the addition. Okay, so that means A plus B first, then plus C is the same of A and B plus C first, then the A is added to B plus C, okay? And that is also sounds trivial. Now let's do some exercise using this, okay? And because of that, okay, we can define A plus B plus C even more. Now, how to define? Well, it's defined to be A plus B and plus C, or doesn't matter, according to the above rule, because those two are always same. So it doesn't matter which pair of numbers you're going to add them together. So in the future, we probably just remove the plus. We don't need to mention plus which 2 pairs of numbers you have to add them together. Okay, and when you say A plus B plus C, that is defined to be A plus B first and plus C. Okay, let's do some exercise. Okay. We try to use above properties to do some computation. Okay, 472 and the two 219 plus 28. All right. First of all, you know, with or without the parentheses doesn't matter because we define to be this, right? So I'm going to erase maybe, that's fine, okay? So what I'm going to do here, I can remove, you know, in the book, let's see, I'm not going to put the parentheses here, okay? When you do this, right? So first of all, this will become a number, right? This will become number. Let's step by step and follow the rules. This is a becomes a number, okay? So this is a one number, but I'm not going to add them together. But this number, you know, by the commutative rule, right? Commutative rule, we can always, commutative rule, we can switch around, okay? So it's 219 and 28 plus 472, okay? Then I can work those two together, right? So now this will be much easier. It's a 219, and then that is going to be a 0 and 0 and 500, right? So it's 500. So then 219 plus 500 is going to be 719. Okay. So actually, what we did here is you can move that any term around in this expression. So in other words, 472, 219 plus 28, I can switch these two by the commutative rule, right? Commutative rule is 472 plus 28 plus this, and then you can work on those two first, okay? That would be 500 plus 219 and 719, okay? Okay, so yeah, if you post the answers, please post to me privately. Don't post in the public. So, and I don't want you to browse as a student. Okay. So this is you know, this is how to, you know, what kind of rules that we are follow, because the rules are very important. If not everybody can do that, you know, later on I find out when we try to simplify some expressions, students will totally forget some rules. And then if you're not practicing enough, and you will make mistakes. Okay, so those are the rules, okay, let's take a look at another problem. Okay, I'm going to give you another problem here. Now, for example, 2 plus 12 and the plus 22 plus 32, right? And the plus, yeah. Okay, and this is a plus 8 plus 18 plus 28 plus 38. Okay, when you're given this, you know, this long line of expression, add them together. All right. I think I just click my name and type. If you want to send me the answer privately, yeah, just click my name and then type. You will see that. Okay. All right. So when you see sequence of numbers, right? You know, if you do by hands, suppose you don't have a calculator, right? And you have to do quickly, and you have to do quickly. You have to do quickly and correctly. Okay. So in that case, and you will search for the, you know, those pairs of special numbers. 238, right, will be, you know, you cross these two, you know, 238, 2 plus 38, right? And then 12, and you see anything you can combine, and okay. And then 12 plus 28, right? Okay, then you can try, you know, doesn't matter, you know, 22, 8, right? Because 2 and 8 gives you 0, right? And then 32 plus 18, right? 32 plus 18 doesn't matter. 32 plus 18. 32, yeah, plus 18, okay? 22, 18 doesn't matter, okay? So here you get 40, and then you also get 40, right? Now, if I do this way, 22 plus 18 is 30, and that is going to be 50. You know, otherwise you can switch. Well, it's not the best choice, but right now they all got the integers. And 4 plus 4, you know, 4 plus 4 and you know, right? And together, 4 plus 4 is 8. 8 plus 3 plus 5 is also 8, right? So 16. Yeah, 160. Okay, so that is how do we solve the problem. The reason we can do that just because we have those rules. Okay, if you use the wrong rules, and then you are not making mistakes. You are making mistakes. Okay. All right, so that's a trivial. If you know the rules, those are the trivial problems. Okay, those are trivial problems. For practice, let's do some exercise. It's interesting. 1 plus 2, okay, plus 3, plus 4, plus 5, and get 20. Okay. You should use the host, yeah, not co-host. Okay. Right. Because I have open another computer for the better recording. If I use the same computer and I'm writing on the screen, and you can hear the the recorded lecture would be, yeah, the voice is not good. Okay, that's the reason. Okay. All right. So if you have this sequence of numbers, addition is easy to do, right? Now the question is, what is the best way to solve the problem? How to add them together quickly, right? So the idea is very simple. What they're going to do is, we learned this before maybe, right? And we reverse the order, right? And that will be 20, that'll be 19, that'll be 18, okay? That'll be 17, and then 16, and so on. So you double it, you add them together, right? You add them together. So you will add those together first, okay? So be 21. Then this will be 21, and this will be 21, okay? And so on, every term is 21. So how many 21s there? Okay, you have a 20 21s. Okay, so that's why you will get 21, 21, right? Now here you have to do the multiplication. This is how do we end up with the multiplication. You have a 20 21s, and this is a so-called multiplication. You have a 20. You have several identical terms. Add them together. This become multiplication. Okay, so that will be 200. 200. You know, there's 20, right? 420 here. Then the answer have to be you have to divide by 2, which is 210. Okay, so you end up with a division and then multiplication. So that's why we have to study multiplication. Multiplication. All right, multiplication. All right, multiplication. When we say 2 times 3, what's the meaning of 2 times 3? 2 times 3 means you have 2 3s. Okay, that's the meaning of the multiplication. So then the answer will be 6. But how about 3 times 2? 3 times 2 is you have 3 2s. That's also is 6. Okay, so it's the same. So therefore, you get 2 times 3 is 3 times 2. Now you can also understand. You can understand that this way. I'm going to, okay, the same picture. Okay, the total 6 here. When we say 2 3s, means I have a two rows of 3, right? Okay, 2 rows of 3. But when I say 3 2s, okay, so I was thinking about this 3 columns, okay, 3 columns. I think about three rows here. Each row there are 3 boxes, right? So that's just think about the same, multiplication the same in a different way, slightly different way. So my conclusion is we have the following commutative rule also for the addition, for the multiplication. Commutative rule. Okay, that means A times B is equal to B times A. Right? A times B times A. Then we take a look at an example 2 times 3 and then times 5. Okay, 2 times 3 and then times 5. I'm trying to compare. When it's similar to the addition, right? And this multiplication, and the 2 times 3 and the 3 times, you can do the 2 times 3 first, right? When it comes down to first, then you give it 6 times 5, then you get 30, right? Then 30. But here, you get 2 times 15, and 2 times 15 is also 30, so they're equal, okay? They are equal. So that means it doesn't matter which pair of the numbers you do the multiplication. So we also have the associative rules for the multiplications. Okay, so A times B and the times C, you can do B times C first, then A times. Okay, A times B times C and A times B times C. So it's the same. Okay, we've used that. We can see that from the example, and this is always true. Okay, using why this commutative rule is good? It's useful. For example, when you do the multiplication, okay, when you do the multiplication, because of this commutative rules, right? So we can define we can define A, B, C in the following form. Doesn't matter which one first, right? Yeah, we use one of them or use one of them. That's the definition. So when I say A, B, C means if you really want to do the computation A times B times C, right, then I have to choose a pair of the numbers first. But doesn't matter which pair of number you choose first, you can end up with the same result. Okay. For example, so using this, I can do the computation. 6 times 4 times 25 times 8 times 125. Okay. So you have a sequence of numbers here, and you do the multiplication. So you can, first of all, you can switch around because by the commutative rule, right? You can switch around. Okay. So what you can do here is you can group this together first. Okay. So 4 times 25 is 100, and 8 times 128. It's actually this is going to be 1,000. Okay, 8 times 100. So we needed to know some important identities. 4 times 25 is 100. 8 times 125 is 1,000. Okay, then you can quickly get, just add 5 zeros to the 6. Okay. Now sometimes you have to switch around. So if I write it in the following way, 4 times 8 times 6 times 25 times 125, then you have to look at those numbers carefully and to see which one should be grouped together first, right? Then you will see, okay, this 2 should be grouped first, and this 2 should be grouped first, and 6 has no relationship with it. So first of all, you can move around those numbers because of associative rules and the commutative rules. Okay, and then 8 times 125, then times 6. So then you get 100 and the 1000 and 6. Then it's easy to see 6. Yeah. Okay. So that is because of those rules we have. Okay, those rules we have. Okay. And then after we study addition and the multiplication, we have to think about the mixture of the mixture. Okay. We have to think about the mixture. For example, like a 2 plus 3 times 5. Okay, can I do the multiplication first? I find out those two are the same. Okay, those two are the same. Okay, and another one is like 2 times 3 plus 5. This will be 2 times 3 plus 2 times 5. Okay, and we can verify this is true. Okay, we can verify this is true. 2 times, they're all equal to 25. The first one, 25 equals here 10 plus 15. So it's also 25, right? And here is 2 times 8, and that is 16. And here is 6 plus 10. That's also 16. Okay, so 16 over 16. Okay, then you find out, okay, this actually, what we're doing here is just multiply this out. Okay, 2 times 3 and 2 times 5. So let me state the following rules here, because those are the rules we're going to, this is called the multiplication. Yeah, those are certain rules. Yeah, so we get A plus B times C is going to be A, B, AC, and the BC. Okay, don't forget that. Okay, and then another one is A times B plus C, and then will be AB, and then will be AC. Okay, so those are the two important rules, and only after you practice enough, you will not forget it. Okay, so otherwise, it's and vice versa. You can converse. You know, sometimes you begin with this, and they can simplify. Okay, let's look at some examples. Okay, and this is a good example. Those above rules are important to use. Okay, 17 times 13 plus 51 times 13. So compute this. Okay, now compute this, right? So you do the multiplication first, and how many computation you have to do? Multiplication usually is more complicated than the addition, right? So you do multiplication first, 17 times 13 and 15 times 13. Then add them together. It takes much longer time. Right? It takes much longer time. So the quick way to do is, you see, just like what we hear, you have a common fact, right? 13, 13. So you reverse using the first formula. You reverse that. That's going to be 17 plus 17 plus 51, right? Maybe you can try this, okay? And then times 13, okay? Then times 13. That's possible, okay? So at least the addition, you just only needed to do one multiplication here, okay? So that will be 8, you know, and the 68, right? 68, and times 7, 13. Then you do the multiplication, okay? And just only one multiplication. Sometimes you're lucky, you can do, you get a very nice number, you know? So 68 times 13, and you can do the multiplication. It's going to be 804. Okay. But if I change the problem a little bit, and the 51, let's see. Let me check. Yeah. So if I have a 51, 17. Let's see. Yeah, sometimes 17 times 13, 51 times 13, and 32 times 13. Now in this case, you have the common factor here, right? So it's the same is true. We have to use the following formula: A plus B plus C and times D. You can AD, BD, and CD. You know, you can extend the above formula to this one, have three terms. So similarly, you get 17 plus 51 plus 32. And I hope if there's a common fact, you take this out, and that is what you can do, okay? You add them together, you already 68, right? And the 32. 68, 32, you know, 68, 32, and that is 100, and then it's 1300. So you can quickly solve the problem. Okay. So these two formulas are important. Okay, and of course, similarly, you have A, B plus C plus D. You can do this, you know, even have more terms that is AB, AC, and AD. Okay, you have three terms. You can multiply them out. Okay, have 5 terms and then 5 terms. Okay. All right, so after we talk about addition and multiplication, we go back to the number line. On the number line at the very beginning, I was talking about how to understand negative number, right? So I choose a point on the number line, and then this is called the 1, right? And 2, you have the same unit and then repeat it. So you get all those integers. Then I probably can have a integer, I can have a number, not necessarily integer, is between 2 and 4, or between 0 and 1, you know, like 1/2, 0.5, right? But on the other side, I can do the same thing, right? Repeat it, you know, measure the same distance, and then that number I'm going to have to call it -1, and that number -2, -3, -4, okay? So this is how do we introduce the negative number, okay? A -1, -2, -3, and those are the numbers we get from the coordinate line, okay? So now, yeah, where's negative? You know, where's the point corresponding to -3? You have to go 3 steps to the left from the origin. Okay, this is the origin. This is the origin on the number line, and that is a point which corresponding to -3. It takes a while to understand negative numbers, honestly, for the human being in the history. You know, our history is only about 5,000 years in Chinese history, right? And European history maybe even shorter. Okay, so it only recently we know this stuff, right? What is 0? What is negative? And the mathematics is pretty abstract, and you don't. Yeah, right now it sounds like a tribute to you at negative numbers, but the first person who is talking about negative numbers, and probably genius guy, okay, understand the concept of a negative number. But if you use a number line, this concept, you know, in number line to mark the numbers, then the left-hand side, well, this go to left-hand side, it's, you know, 3 steps to the left, right? Well, there should be a number corresponding to that, and it's similar, right, to the 3 steps to the right. So 3, right? Yeah, that's a 3. Then I have to choose a sign there. I put a negative, okay? You can choose any sign, you know. This is you have freedom, you know, but everybody accept this called a negative. You can choose, you can also call that number 3 star. It's not a big deal. Okay, 3 star means the number 3 steps to the left from the origin. So there's a pointer, okay, corresponding to that number called 3 star. That's fine. But you can also, but tradition right now use a -3. Okay, so that is you see in my notation, you can choose, you can define your own notation. Maybe on the another planet, aliens actually use a different notation for the -3. That's fine. -2. right? And but the idea is still the same. So mathematics, you can use mathematics to communicate with aliens, okay, many years in the future, okay. So just because the questions or notations will be different, just the language, our language, right? The pronunciation is different, and even the letters are different, but we can do the same. We are meaning the same thing. So, all right. So this is a coordinate line, and so given a number, here's a very abstract definition. Okay, what is a negative x? Okay, given a number x, given a number I just called x. Okay, what is negative x? Okay, now here's the definition. Okay, the negative x is the number. Okay, okay, that we add to x to give to get 0. Okay, let's say get 0. Okay, so that means there's some number in the world. Okay, this number, if it's added to x, it should be 0. Oh, that's trivial, right? Just like how do we define the square root 2? Well, have you heard about square root 2? Yes, I think Michael maybe already heard about, right? Square root 2. So how do we define square root 2? In mathematics, you have to give an abstract definition. Okay, negative, if you give me x, and the negative x means the number and that we add to x is to get 0. Okay, that's a unique number then. Okay, that's the abstraction. Okay, so negative 2 added 2 is going to be 0. Okay, is added to 2 is 0. So that's our notation. And on the coordinate line, yeah, we right now, when we do that, define the addition, we only add positive numbers. Okay, now we can work with the negative numbers together. Okay, at the very beginning when we're talking about addition, like 2 plus 3, that's a positive numbers. So come on, right? That's how do we do that at the very beginning? The Asian people go outside, and this person picked up 42 apples. This person picked up 3 apples, so when come back together, that's addition. Okay, but they're never talking about the positive number to a negative number, right? So now we expand our numbers to negative numbers. Then we also expand our multiplication and addition to the negative numbers. Okay, so that's this is a gradually we expand our knowledge on the okay, and then okay, addition is okay. The numbers can be negative, right? And we still have the associative rule and the commutative rules. Okay, and yeah, the negative number okay. So let me explain to you. Now let's talk about the multiplication among the numbers. Okay, multiplication. So addition rules should be applied to all the numbers, including negative numbers. Okay, all the rules. Okay, the rules for additions, the rules for 2 rules for multiplications applied to all the numbers, including negative numbers. Okay. Here's a question. Okay. Why negative 1 times 3 is going to be negative 3? Okay, so right, negative 1 is a number. Okay, right? We already defined that. This is a number on the left hand. So what is a negative number? Negative 1. What is negative 1? Negative 1 is a number, right? Is a number when added to 1 should be equal to 0. Using this, maybe we can prove it. But that's a definition of a negative 1. Negative 1 is a number, some mystery number, right? It's going to be added to 1 is going to be 0. Okay, and how do you prove -1 times 3 is going to be -3? But -3 is a number added to 3 is going to be 0. Okay, so that's what we know from the definition of -1 and -3. And why -1 times 3 is going to be -3. Done. Okay. See, we're going to learn in proofs in mathematics. Proofs. I'm pretty sure, students in elementary school, middle school, and high school here, that almost no proofs through the whole 5 years, 7 years study mathematics. Okay, that will cause some troubles in the future. Okay, and that's why we have to emphasize the proof sometimes. How to prove that? Okay, now in order to prove -3 plus 3, you have to prove that this always, of course, is a number, right? This is a number. I want to make sure, check, right? I want to make sure whether this number added to 3 is going to be 0. If it's a 0, then -1 times 3 is, by definition, is -3, right? Okay. All right, so we how do we do that, right? And the -1 times 3, and we have to use a fact is 1 times 3 is always 3, okay? 1 times 3 is 3. Okay, this is already defined, right? 1 times 3 is 3, okay? The reason, yeah, it's a 1 times 3 is 3. Then 3 is going to be a common fact, so it's -1 plus 1. And then by definition of -1, that's going to be 0. 0 times 3, okay? 0 times 3 is 0, okay? 0 times 3 is 0. When we do the multiplication, right? In the 0, 1 times any integer is 1, right? And then record this, I did not even mention that, for the multiplication. 1 times any number is that number. 0 times any number is always 0. Okay, 0 times any number is going to be 0. All right, 0 times any number is 0. All right, and right, so we have to explain, why this is true. Okay. Now we accept the fact. Okay, -1 times x is going to be -x. Okay, this is not a trivial fact. Okay, this is actually is always true. Okay, so we state our rules here. Okay, -1 times x is going to be -x. Okay, this is the important rule we can use. Okay, and this different concept here. -x is not defined to be -1 times x. Okay, but we prove that it's going to be -1 times x. Actually, -x is the number when it's added to the x, it's going to be 0. Okay, so don't be confused. Yeah. So then using this, we have other rules we can use, and I don't have much time. I just say it's very natural. -x times y is going to be -x times y, and something like that x times -y is -x times y. Those are the rules we have to get familiar with. That -x times -y is going to be x times y. Okay, so those are the rules we have to follow. And let me talking about the last one, -x plus y. Okay, and that is going to be -x plus -y, okay, and the y, okay, you have to give a proof, okay, so let me prove that, okay. Prove this, okay, we have to use some formulas to prove it, okay, so it's -x plus y, by above the formula, it's -1 times x plus y. Then this is a product, a number and the sum of the two numbers. So you have to multiply this out. So it's -1 times x plus -1 times y, right? And then again, you use about this is product is going to be actually is going to be -x. And then that's a proof, okay? So when you do the proof, you have to use the rules stated in the book and use them to verify these identities. Okay. So step by step, you just like build a building, then a mathematical building. And then those are the rules that do not contradict with each other. Okay, that's the great of mathematics. Okay, they do not contradict with each other. And mathematics is not science. Let me repeat again. They just the rules. They're already there. They never got a contradiction. That means the book written 200 years ago in mathematics, as long as there's no computation mistakes, this is always true. Okay, you don't need to say, hey, that's totally wrong, I can rewrite it. It's not like a science. Science is like a biologist, discover something 20 years ago. They're totally doing a different way to think about it. They just conclude, based on few examples, conclude that this is true. But later on, more examples discovered, more samples, studied, they find out, oops, that's not the whole picture. Then they modify, sometimes completely throw away the older theory. So that's why you cannot use the textbook, biology textbook 20 years ago, and now in the college. But you can definitely use a textbook for calculus 50 years ago, and you can learn the same mathematics, okay, using textbook 50 years ago. That's just because mathematics they don't contradict with each other. All the rules they do not contradict with each other. So finally, you only make mistakes just because you forgot the rules and use the wrong rules or by mistakes, by do the computation mistakes. Okay, I stop here, and next class I'm going to talk about subtraction and some other rules, and we'll probably discuss more examples, reciprocals, all these kinds of things, division, subtraction. Okay, and this is a quick review about that. I hope you get some, understand better this concept. Okay. We're not solving hard problems, but we do need to understand the concept.